Hello, my name is Giro Ritvo from Migal Institute and Tel Hai College, and I will present a follow-through photocatalysis device. When we are talking about remediation of pollutants, then usually we require processes that are either expensive or have polluted remains. For example, activated carbon, you have a polluted solvent that needed to be treated, and membrane filtration, you have polluted brine. Advanced oxidation processes, on the other hand, may deliver a very good alternative, because if you are able to achieve full mineralization, then you have no pollutant remains, and it's relatively low cost. You don't need any replacement of solvents or membranes, and it can be tailor adapted to the pollutant in case. So we planned a device that is made of two concentric cylinders. In the interior cylinder, we have a UV lamp, and between the inner cylinder and the outer cylinder, you have the flow of the effluent mixed with the catalyst. At the top of the device, we have a filter that avoids the catalyst from going out of the reaction chamber, and it's recycled back to the bottom of the chamber. So we fill the chamber with the catalyst, and we let the effluent flow through it, and the catalyst is mixed with the effluent, and the UV light irradiates everything. The membrane avoids the catalyst to go out, and we collect the treated clean water from above. I will show a few results. For example, when we treated acetaminophen with this device, if we do it with no catalyst, only with UV light, then we get a zeroth order photolysis. If we use ectorite as a catalyst, then we get more or less the same, but slightly better, but the same zeroth order reaction. But if we used titanium dioxide, then the reaction changes completely, and we get a second-order reaction. It's interesting to mention that if we avoid the air inside, then after several minutes, the reaction stops and becomes to be, again, a zeroth order. That means it really can prove that oxygen is a limiting factor in such reactions. We have similar results for several compounds, and most of them pharmaceuticals. Of course, that our device is planned mainly for polishing effluents. So if we try to treat relatively low concentrations of pollutants, 2 ppm, when we shut on the light, then the concentration goes down depending on the retention time, and reach the limit of detection, almost zero. And when we shut off the lamp, then the process stops and the concentration rises again. We managed to prove complete mineralization by Q-TOF LCMS screening of the outlet effluent. So our device is effective and can be used for complete mineralization of pollutant. Retention time for complete removal of 2 ppm varied between 40 and 100 minutes, and we can be adapted by changing the UV energy or the catalyst concentration. Thank you very much for your attention.